Hi, Algebra 2 local students. This is probability day 3. Today we're going to talk about probability using the word or as compared to what happens when you use the word and, like we saw in the last lesson. The start of today's lesson is a quick review, so I'd encourage you to hit pause right away in the beginning, try these questions, and then check back in with the answers. Okay, here they are. Number 1, the probability of snow on any given day in Fairport is 7/12. What's the probability of it not snowing? Well, that would be 5 out of 12 then. We've done that same type of question with percents so far, so hopefully that makes sense to you, that the probability of it not snowing and that probability of it snowing has to add up to a total of 12 out of 12 or 100%. When rolling a die, what's the probability of getting an even number and a prime number? You're looking for the intersection between these two groups. Here are the even numbers, here are the prime numbers. They only have one number in common, so the chances that will happen is 1 out of 6. Okay, moving on to cutting up the numbers 1 through 10, putting them into a bag. What's the probability that you pick a number that is an odd number and a multiple of 3? Whenever you see that word and, you got to look for the intersection here. Okay, so we've got these numbers are odd and there also happen to be multiples of 3. So there are 2 numbers out of 10 that are odd and a multiple of 3. Last one, what's the probability of picking a period in our school day at random that ends with a 5 on the clock? Well, this would be a lot easier if we happen to be in school right now. Here's the ones that I remember ending at a 5. First and then second, because we have that announcements, right? So first, second, fourth, sixth, and eighth all end in a 5. So that would make it a 5 out of 9 chance that pick a period at random, the clock ends in a 5. Okay. Today what we're going to do is we're going to move on from there and talk about disjoint probability using the word or. So here's what's going to happen today. If I say, what's the probability of an even number on a die or a number less than 5? What we're going to do is we're going to take the number of items in the first event, add them to the number of items in the second event, but then we have to subtract out the intersection. So we have to subtract out what's in common between those two groups, because otherwise we would have counted them twice. So for example, if you roll a die, the first event of getting an even are these numbers here, 2, 4, and 6. The second event of getting a number less than 5 are 1, 2, 3, and 4. But notice how if I really calculate the probability here, it would be 3 out of 6 plus 4 out of 6 for a total of 7 out of 6 if I don't do this step over here. 7 out of 6 is really impossible to happen. You can't have this happen more than 100% of the time. So we're going to say that this is 3 out of 6 plus the 4 out of 6 here. But then from that, we're going to subtract the 2 and the 4 because they occurred twice. So if you subtract out 2 out of 6, we now have a total probability of, there is a 5 out of 6 chance that we would roll an even or a number less than 5. So like I mentioned a second ago, subtracting out that intersection helps to avoid what we would call double counting. Okay, we don't want to count the 2 and the 4 twice. We definitely want to count them at least once. So if you kind of follow this logic of probability of first plus the probability of the second event, then subtract out the intersection, which is the same thing as the probability of and happening. Probability of an even and a number less than 5. That's what that intersection really is, which is what we were doing all in the last lesson. Let's see if we can do a little bit more practice with this. Okay. So the probability of getting a 3 or an odd. Well, the probability of the first event is 1 out of 6. Okay, and there's 1 3 on the die. The probability of getting an odd would be 3 out of 6. Because remember that in these events, chances I get a 3 is just getting the number 3. The second event would be getting a 1, 3, or 5. Is there any overlap between those two groups? The answer is sure. They both have the number 3 in it. So the intersection is the number 3, which happens to be 1 out of 6. So we're going to add the first 2 columns and subtract out the last to get the total probability in this case of, well, 1 plus 3 is 4, minus 1 is 3. Okay, so the answer to that first one is 3 out of 6. Next one, what's the probability that I get a prime or an odd? So remember, the prime numbers are 2, 3, 5. So there's 3 out of 6. The odd numbers are 1, 3, 5. So there are also 3 out of 6. Does that mean that there is a 100% chance that I roll the die and I get a prime or an odd? And the answer is absolutely not. What if I got a 4? That's not going to be true. What if I got a 6, right? There's 2 counterexamples. So that's why you have to subtract out any overlap. What's the intersection here? So the intersection is that they both have the numbers 3 and 5. So you're going to subtract out 2 out of 6. 3 plus 3 minus that 2 would be a final probability of 4 out of 6. All right, keep on going. What about prime or even? So here's the primes. The evens are 2, 4, and 6. So again, it looks like those probabilities, if I just add them up, 3 out of 6 plus 3 out of 6, that there's a 100% chance of this happening, but we have to subtract out any overlap. The overlap in this case is they both share the number 2, so there's one number that they have in common. So 3 plus 3 minus 1 is a total probability of 5 out of 6. This is it all going too fast. You guys just hit pause, email me with some questions, and we'll figure it out. All right, what about a number bigger than 3 on the die? So that would be 4, 5, and 6. And then the evens are 2, 4, and 6. So there's 3 out of 6 plus 3 out of 6 again. Okay, but is there any overlap between those two groups? The answer is yes. They both have the number 4. They also both have the number 6. So we're going to subtract out 2 numbers that they have in common because I would have counted them twice. 3 plus 3 is 6, minus 2 is a final answer of 4 out of 6. And the last case, probably that I get a 2 or an odd. Okay, so the probability that I get a 2 is a 1 out of 6, right? There's only one of those. Probably that I get an odd is a 3 out of 6. And I'm hoping what you're noticing here is that sometimes there is no overlap between the two groups. So if there's no intersection, you technically don't have to do anything to subtract anything out. There's 0 numbers in common between these two groups. So 1 plus 3 is 4, and that's the final answer. There's a 4 out of 6 chance that that will happen. So I think it's easiest to kind of relate to what's happening with dice here. Well, let's actually extend our practice a little bit further and talk about what happens in a deck of cards. So find the probability, if you draw 1 card from a deck, that you get a red or a queen. So what we have to remember is, let's first talk about the probability of red. Okay, the probability of red, well, half the cards in the deck are red. So that's 26 out of 52. When you see this word or, I want you to automatically think that you're going to add the next probability to that. So how many queens are in the deck? Well, in the deck there are a total of 4 queens. So as of right now, your probability should be 26 plus 4 out of 52. However, is there any intersection that we should be subtracting out? Is there any overlap between the group red cards and queens? And the answer is yes, there are 2 cards that would be both red and queen. We've got the Queen of Hearts and we've got the Queen of Diamonds. Right now I've counted them here and then I counted them again here. So that we avoid that double counting, you're going to subtract out 2 out of 52. And if you kind of combine those numerators, 26 plus 4 is 30, minus 2 is a total of 28 out of 52. And that's the final answer for part A. All right, let's keep going. So the probability in the next case that you get a heart. And if you're not really, super savvy with that deck of cards, I did post that link on the website. I think it's even in color, guys. So that's kind of nice that if you have a color printer at home, you can print that off for yourself. All right, hearts, there are 13 in the deck out of 52. It's half of the red cards. Plus, how many aces are in the deck? So the aces in the deck, there are 4 of those, just like there's 4 queens, 4 kings, 4, there's 4 of an individual type of card. So then at the last step, I have to subtract out, is there any intersection? Are there any aces that are also hearts? The answer is, yeah, there's 1. You're subtracting out the ace of hearts, essentially. You counted the ace of hearts here, and you counted it again here. So when you subtract out that 1, the final answer here is 16 out of 52. Okay, last one in the card section, we got the probability of black. So probability of black, do I have a black marker? Look at that, I do. Get fancy here. Probability of black is 26 out of 52, plus the probability that you get a face card. So face cards, we haven't talked about those maybe a lot within our card lessons, but there's 12 face cards in the deck. Okay, you got 4 jacks, 4 queens, 4 kings, for a total of 12 face cards. And then the last part is, are there any black face cards? And it turns out there are 6 of them that you'll have to subtract out, because there are 2 black jacks, 2 black queens, and 2 black kings that you would have counted twice if you include them in black and then you include them in face. So altogether, if you combine these, it's really going to amount to 26 plus a total of 6 over here. So that seems like it's going to be 32 out of 52. Okay. So take a moment there, really make sure you understand what's going on with that deck of cards. You know, certainly we wouldn't want you to be at a disadvantage because you didn't know what was in the deck, but I'm more concerned that you understand. Do you understand this new rule using the word or? Add the probabilities together, subtract out any overlap. Okay. Let's go on to example 2. A bag contains 5 red, 4 white, and 3 blue marbles. Find the probability that each of the following will happen. So the first one says picking a red or a white. So how many do we have total in the bag? 5 plus 4 plus 3 is a total of 12. So the probability that I pick red is going to be 5 out of 12. Plus the probability that I pick white, and again, I'm doing plus because I see the word or. Probability of white is 4 out of 12. Does it indicate somehow that in this bag there are marbles that are both red and white at the same time? I guess in the real world that's possible, guys, but these are just, you know, distinct colors. They're either red, white, or blue. There's really not any overlap here. Okay, so I don't have to subtract anything for the intersection. You actually will just get 9 out of 12 as your final answer. And that's it. So picking a marble out of this bag, you're not going to ever have any intersection. Okay, if I want to do red or blue, similarly, 5 out of 12 is red, blue is 3 out of 12, for a total of 8 out of 12. No intersection there. Can't pick red and blue at the same time just by choosing a single marble. Okay. If you wanted to get really fancy, you would impress all your friends and tell them that these events are mutually exclusive. You can't pick a color or marble that has more than one color on it. So you can't pick red and white at the same time. But we don't really have to be too familiar with that word. Going on to the last page of practice, I actually want you to hit pause here and see if you can do number 3 at the top, which is choosing a letter at random from the word mathematics. Find the probability of getting the following. I'll show you my answers, and then we'll do just that bottom practice there. Okay, so if you want to give this a shot, hit pause for a sec, and then check out that in part A, probably that you get an A or an M would be 2 11s plus 2 11s. There's 2 A's, 2 M's. There's no intersection between those 2 events, so therefore it's 4 11s. Probably that you get the letter occurring after N or a vowel. So there are 3 letters in here that are after the letter N, the 2 letter T's and the letter S. And then the vowels would be the A's, the E, and the I. So there's 4 of those for a total of 7 out of 11. No overlap there. What would have been overlap would be the letter O and the letter U, because those are after that letter N, and they're also vowels. However, this word does not have those letters, so that's why there's no intersection there. What about a vowel or the letter A? Well, there's 4 vowels, there's 2 letter A's, but aren't both of those letter A's already counted here in the vowel column? So you have to kind of subtract those right back out again anyway to get a final answer of 4 11ths. Okay. And the last one, a vowel or a consonant, would be all of them. If there's 4 vowels, then the rest of them are consonants. So if you add those up, you would get 11 out of 11. If I said a vowel and a consonant, there's no way you can do both of those at once. So that would be a 0% chance. You would have 0 out of 11 for that case right there. And the last thing that we're going to see is just some mixed practice with what we did yesterday and, not to use this word, and what we're doing today with the word or. So you just have to, when you're reading these questions, look very carefully for the word and versus the word or, so we know what we're looking for. And is just the intersection, or is add the events and subtract the intersection. Okay, suppose that you roll a single die, find the probability of each. Probability of getting a 2 or a 4. So probability of a 2 is 1 out of 6. Probability of getting a 4, also 1 out of 6. Is there any chance I can get a 2 and 4 at the same time on the die? No chance. So the final answer there is 2 out of 6. Part B, a number greater than 2 and an even. Whenever I see the word and, I'm just looking for the intersection now between these two groups. What do they have in common? So numbers greater than 2, 3, 4, 5, 6. The even numbers, 2, 4, 6. What do these groups have in common? They both have a 4 and they both have a 6. So there are two numbers out of 6 that are greater than 2 and even at the same time. Okay, moving on to part C, an even number or a multiple of 3. So even numbers, there are 3 out of 6, right? A multiple of 3, just be careful with that. The multiples of 3 on the die are 3 and 6. So there are 2 numbers out of 6 that are multiples of 3. And the last part is, are there any even numbers that are also multiples of 3? And the answer is yes. The number 6. 6 is a multiple of 3. It's also an even number. So we've got to subtract that out. Subtract out 1 out of 6 so that we don't count it twice. Final answer for this one is 4 out of 6. This definitely takes a little while to get used to. Okay, so make sure that when you're doing the homework for practice, you refer back to these examples. How about an odd number and a prime number? Okay, looking for the intersection. The odds are 1, 3, 5. The primes are 2, 3, 5. So notice how they both have 3 and 5 in common. Okay, so the overlap there is 2 out of 6. Okay, so I think we're pretty good with the dice examples. Couple last quick ones for some cards and things like that. Number 2, a card is chosen at random from a standard deck. What's the probability that you get a king or a spade? All right. First event is getting a king. There are 4 kings in the deck. Second event is getting a spade. And I'm using, remember for or, we're going to add. Or means add. There are 13 spades in the deck out of 52. Is there any overlap to subtract out? Are there any cards that are kings and spades at the same time? Sure. How about the king of spades? So you're going to have to subtract out 1 out of 52 for a total answer here of 16 out of 52. Okay. You choose a number at random from 1 to 100. What's the probability that you choose a number that is even and bigger than 80? Okay, we're looking for the intersection here. So I'm not going to list all the possible events here, because if I listed all the even numbers 1 through 100, that would take a while. But why don't I actually just start with the numbers that are bigger than 80, but are also even? So what would we list? We would list things like 82, 84, 86, 88. We have 90, 92, 94, 96, 98, and then finally 100. So it looks like we've got a total of 10 numbers here. Remember, my total group was the numbers that are from 1 to 100. So there are 10 numbers out of 100 that are both even and happen to be bigger than 80. Last one, the month of February during a non-leap year has 28 days. What is the probability of picking a day at random? And it is a Saturday or a Sunday. Okay. So for this last one, the number of Saturdays that we have in February for 28 days would be 4 out of the 28. We should also have 4 Sundays. Can a day be a Saturday and a Sunday at the same time? I don't think so. So the final answer here is 8 out of 28. Okay. All right, that's it for probability day 3 with or. Let me know if you have any questions. See you guys.